So good morning everyone. My name is Deepak Gupta, additional HOD CS department. Okay, and the topic for the session which we have decided is generative AI and under the title of AI for Atmanirbhar Bharat. Okay. So as we know that if we want to work with any GenAI application, few requirements are there, because when we talk about the generative AI, the first point comes into the mind is we are going to generate the content. And if we talk about the content generation, we are not limited to only the text generation. We can generate the images and the other variety of data also. Okay. So the core discussion in this session will be on related to the text related data. Okay. So if we are talking about the generative AI for text only, so for that purpose we need to understand how the machines are going to handle the text data. So for that purpose we need to start or we need to understand the core difference between the terms NLU and NLG. Okay. As we already know, NLP is the common term and two subdomains are there. One is called NLU and the second is called the NLG. In NLU, we basically talk about how machines are going to interpret the data, how machines are going to understand the human input. Because if we can process something, how a machine can process the same thing, that capability we are trying to generate in the machines. So that's why this NLP is there. This is not a new concept, but as we know that the availability of data is one of the factors, such that we can claim that now we are ready to work with different number of models. This NLP, AI and all these terms were introduced later, but the point is, at that moment of time, we were not having the sufficient resources to process the data. Second challenge was we were not having the open data sets through which we can practice and other model development may be there. Okay, so the basic term is here. If we are going to process something, we need the huge volume of data such that my model can respond or my model can take a decision for a given scenario. That is the core objective behind the AI. So if we are going to differentiate between the two terms, one is the NLU and NLG. So first pipeline we should understand how machines are going to interpret the human input. Once this pipeline will be ready, then only we can talk about if machine is ready to process the human input, how we can generate the human-like content as an output. Okay. So if we are talking about any generative AI applications, any generative AI tool like Claude is there, ChatGPT is there. So one popular model is working behind all these models or applications, or that is the transformer models. So before starting the working of the transformer model, we need to understand how the things are going to be processed at the back end. Because transformer model is one of the model which is working on the concept of the self-attention. Okay. But everything is possible. We can cover all the concepts only and only if we can understand how the actual processing is going on. Means input to output generation is there. Okay. So in the context of that, we are going to first start with the understanding of this pipeline. So the first thing here is, if we are going to start with the NLP applications, then what will be the step number one? First, we are going to split the data into the smaller size units. Okay. Any guesses what will be the name of that unit? Token. That will be the token. So how to exactly define a token?
The smallest unit.
The smallest. Any specific word for that? Unique. Means if one statement is written, I am going to split it into the words. So how can I claim that each token will be unique in that input statement? How can you claim that a token is always a unique value?
If a sentence.
A token is simply the collection of values. Clear? If I am giving you a document, that document may have the set of paragraphs. Can I say that that paragraph may be treated just like a token? Yes or no? No. Then how can you claim that your definition is correct, like smallest or some smaller unit of data? The correct definition for a token is the smallest primitive unit of data is called a token. And the context with respect to which we are going to define the smallest word, that will be the deciding factor. If we are talking about a character, we are talking for a word, we are talking for a particular sentence, or we are considering one paragraph for the entire document right now. Okay, if we are going to focus on sentence level processing, in that case your sentence will be the token. If we are taking the example of any kind of spelling checker, in that case we need to read each word character by character. If character by character reading is required, in that case we can say that a token will be a particular character. If we are going to process the data where the number of words we are going to process, it means in that case each word will be a token. So your definition is the smallest primitive unit of data is called a token. So depending upon the context or the requirement, we can differentiate whether we are going to consider a token just like a word, that may be a character, that may be a sentence, or that may be a paragraph or an entire document. Because when we are going to process the data, first we need to collect the data. This is not mandatory that all the data will be available at a single source. We need to sometimes collect the data from the different documents. In that case, document number 1, document number 2, document number 3. Okay. These are the documents from where we are going to collect the data. So the clear definition for the token is the smallest primitive unit of data. We can consider a sentence as per the requirement as a token, word as a token, and number of other terms are possible. Okay. After dividing or splitting the data into the tokens, what we are going to do? The second phase of this NLP framework is, one is lexical analysis, where we are going to generate the tokens. Second, syntax analysis. In syntax analysis, what is the requirement? We need to verify whether the input is following the language rules or not. If we are talking about the English language, it means whether the sentence is grammatically correct or not. Done? If the sentence is grammatically correct, the third phase of this life cycle is semantic analysis. What is the objective? Meaningfulness. We need to check the meaningfulness. It means we need to verify whether the sentence is grammatically correct, then that is producing any meaning or not. Sometimes there is a possibility that may be syntactically correct, but when we try to interpret it, the number of conflicting outputs are possible. So that may be meaningless for a given context. So we need to check the meaningfulness of that particular statement. So that is done in the third phase of this life cycle is semantic analysis. The next phase in this life cycle is that is the discourse analysis. In discourse analysis, we talk about the meaning, but with respect to overall context, not with respect to a single meaning. Single sentence. One single sentence may be syntactically correct, that may be semantically correct, but we need to verify whether the sentence number 2 is in the same context in which the sentence number 1 was written. It means we need to check this connectivity. So entire context analysis that is covered under the topic that is called discourse analysis. And the last phase of this life cycle is pragmatic. What is the objective? We need to check the intention behind each word or statement that we are going to use. Because sometimes if we start with the literal meaning of any particular statement, that may be ambiguous. The intention for which I am going to use that statement, that may be different, but how you are going to interpret it, that may be different. So two different meanings are possible. So that's why that intention analysis is again required if we are going to process the text. And this also happens with any kind of AI tool like ChatGPT and Claude and all. If your intention is different, if you are not going to clarify this intention to the ChatGPT and you are simply writing a prompt, the output will be there because that ChatGPT or Claude is responsible for generating the output, but the intention is not clear. So the output which is generated by the AI tool, you may say that is irrelevant, but that is relevant because that input was interpreted like in that particular context. Okay, so what you have to do, people suggest that we may need to submit a valid or appropriate prompt. Appropriate prompt means that statement along with the that intention for which particular scenario we are going to generate the data. If everything is mentioned in that particular input prompt, then the chances of irrelevant output that will be reduced. Okay, so this is the thing. Now the second is, after considering all these pipelines, what we have to do, different types of tokenization mechanisms are there. We can, as we know, we can split the data into the tokens, where a token may be a sentence, that may be a character, that may be a sentence, that may be a paragraph. So number of tokenization approaches are there that we can apply. After converting the data into the tokens, next important thing is there, that is called stop words in this NLP pipeline. What is the meaning of the stop words?
The words that are not so useful in identifying the meaning of the sentence.
That
does not contain meaning, but not giving much meaning to the sentence.
So the words that are not that are frequently not used to grab the meaning of the entire sentence.
okay. If we are going to start a conversation on a particular topic, then the first requirement is, whatever statements I am going to use, you may understand my statements if you are having the understanding of the same language. First requirement. Second, in order to claim that this statement is syntactically correct, we need to follow the grammar rules of that language. So if any statement is syntactically correct, then in order to make it syntactically correct, sometimes we are going to follow those rules and few new words will be added in order to complete this requirement of syntactic structure. Okay, so if we are talking about a travel plan, in that travel plan, the objective is we are going to make a planner for a particular destination. This will be the source point, this will be the destination point, this will be the budget. But in order to complete all these statements, we need to use some extra words just like the characters, which are not having their own meaning, but they are required in order to complete the language requirements of that particular thing. So that's why this is the requirement. So those stop words, if we are going to split the data into the tokens, then two terms are there. One is the corpus and the second is called the vocabulary. Corpus is what? Whatever content is given, the entire content we can consider just like the corpus. If we are going to split the content into the words, then each word will be considered just like a token. Okay. So in that case, if the paragraph is given and that paragraph is having 600 number of words, and we have applied the word tokenizer, it means all 600 number of words will be considered just like the corpus of that particular document. Correct? Second term is there, that is called vocabulary. How to differentiate vocabulary with respect to the corpus? Vocabulary contains only the unique words present in the corpus. Correct? Now the question is, if we are going to generate the vocabulary and the chances of repetition of words in the corpus is high, number of words may be repeated. In that case, the size of the vocabulary will be smaller in comparison with the size of corpus. But the second challenge is, if we are not working properly on the stop words, he was going to Delhi, was to, these are not the actual root words. Going to Delhi, go is one of the word, Delhi is one of the word, he is representing someone, but is and to, they are just used to complete this particular statement. So while drafting this vocabulary, is there any need to keep all these words also in the vocabulary? No. So it means if we are going to generate a vocabulary from a corpus, we need to make this point clear that stop word should not be the part of the vocabulary. So stop word removal is one of the things that we need to consider while generating the vocabulary. Clear? One thing. So first we started with the corpus. Whatever content is given, if we are going to consider it just like the word tokenizer, it means each word will be considered just like a token. Number of words, all the words including stop words, all the punctuations, they will be considered just like the part of the corpus, and each individual unit may be treated like a token. If there is any question mark, that will be a token. If there is any full stop, that will be a token. Okay. While drafting the vocabulary, first system is we can delete all the stop words. That will reduce the size of the vocabulary. Second, do we need to store any punctuation present in the corpus also in the vocabulary? If any hyphen is there, if any question mark is there, if any dot is there, do we need to store? But while drafting or while generating the tokens, my tokenizer will generate one separate token for all these things. It means first we are going to ignore all the stop words, that will reduce the size of vocabulary. Second, we are going to ignore all the punctuations, that will reduce the size of the vocabulary. Okay. Third thing, whatever, sorry, repeating words. So vocabulary is always containing the unique words. Because corpus, there is a possibility that corpus may have the duplicate words. But vocabulary means set of unique words. So no repetition is allowed. But repetition is allowed in what context? Your data is case sensitive. Your observation is correct. Data is case sensitive. It means that if the same word is written in uppercase and the same word is written in the lowercase, my tokenizer will generate two different tokens for the same thing. So if you will check the unique terms, you will not be able to differentiate कि this term is different from this term. Your system will generate two different tokens for the same word. If Kanpur is written in uppercase, second time Kanpur is written in the lowercase, so your tokenizer will generate two different tokens for the same word, that is the Kanpur. But if we talk about the city name is equal to Kanpur, then both are having the same meaning. So while drafting this vocabulary, do we need to maintain both the Kanpur tokens or we need to work with only one? Because Kanpur will be Kanpur. So we can start with only one. Okay. So the second requirement is there that we need to check the case sensitivity of the input also. Okay. Because once you will try to identify the vocabulary, you will make sure unique tokens will be there in the vocabulary. But this is one of the problem. If you will not take care of this particular thing, then same word may appear number of times in your vocabulary again just because of this problem, because your data is case sensitive. That is the requirement. So that step we need to complete. Next term that we need to execute in this pipeline, that is called stemming. That is a new term. Stemming is what? Sometimes what we have to do, suppose if I consider a scenario, an online job search portal. Okay. And on that portal, a particular job post is listed. You are going to visit that particular portal and you are looking for a particular job post. And you are not confident कि how many number of job posts are related depending on your requirement. So what you will do? In your search tab, you will try to type something. Okay. The problem is in that job description, that content is written. For example, I am looking for a vacancy where a software developer is required. Okay. So what I will search for the software developer. Suppose in the job post one word is written, that is a person must be having any kind of expertise in developing the prototypes. So developing prototypes, it means they are also looking for a developer. You are also looking for a job post where the development is one of the requirement. Product development or the project development is the requirement. But the problem is your input query is having the word that is called developer. In job description, the word is mentioned that is the developing. If you will go for 100% keyword matching, will you get any response for this combination? Developer and developing. In job description, the word is used just like the developing, and you are using the word that is called developer. If no such job description is there where the developer word is used, it means in response you will not get any particular job post. Why this problem is you are facing? While developing a prototype, it means they are also asking for the same thing, and you are writing a query for a software developer. Intention is same.
Yes.
But what is the problem? Because you are talking about the letter to letter matching. developer with developing. If I talk about any kind of rule-based matching, then I will not get any output. Then what is the solution? In place of directly comparing these two words, one is available with respect to the query from the user, second with respect to the job description which is provided by the company. If I will try to find out the root word for all, both these two words, developer, root word is develop, developing, root word is develop. If I will find out this root word from these two words, then that search will be completed. Is there any possibility that we can generate a response with respect to the same query? So that is one of the requirement while we are working with the text analysis. Okay, that is one of the things. So one term is there that is called stemming. For the stemming process, stemming is a rule-based text normalization. So what we are going to do, that is a kind of text normalization technique which comes under the category of the text pre-processing. So whenever we talk about any kind of model development, one of the initial phases there that is called pre-processing. Right now we are working with only the text. So the step is there that is called text pre-processing. Stop word removal, that is a part of pre-processing. Punctuation detection and removal, that is a part of pre-processing. And this next technique that is called stepping or lemmatization, again that is a part of the text pre-processing. So what we are going to do as per the definition, stemming is a rule-based text normalization technique that reduces the words to their root form by removing prefixes or suffixes. Any guesses? What we are going to do? That is the rule-based normalization technique, and we are going to convert the words into their root form by eliminating prefixes and suffixes. So what is the meaning of this statement? Any example? Prefix elimination, suffix elimination. So if we are talking about the developing, so in developing ing, developer er, if we will remove both the words, both the suffixes, then we will get the root word that is called develop. Then we can go for the complete matching character by character, because in the job description we are getting developing. From developing, if I will erase this ing part, then I will get the word, root word is the develop. From the developer, if I will delete the er part, then I will get the word develop, and if I will continue with the character to character matching, then I will get the solution that this word is mentioned in the job description, so that's why that particular job code should appear in the response of my search query. That is possible. Okay, but one problem is there in stemming. Take now look at the examples. Just look at this one. Running. If I consider the example of running, and we are going to apply the technique that is called stemming. The idea is we are going to eliminate prefixes and suffixes. So if prefixes and suffixes needs to be deleted, so running will be converted into run. Second word is there that is called runs. Again that will be converted into run. Third word ran. Any suffix? No. But what will be the root word for ran? Camera. So can we claim that stemming is going to solve all the issues? No. Because the limitation was it will work only with the prefix and suffix. So if we are going to start with any kind of pre-processing, where this is a possibility like ing, es, ed, if we are changing the tense form, present to past tense, future tense, take any continuous form, then few suffixes will be added. Using that stemming process, we can eliminate those suffixes. Then we can say that now we are going to, there is a possibility that we can get the root word, but we are not 100% confident that every time we are going to generate the root word. Like few other cases are there, I will discuss, where applying the stemming, although we are having the suffixes in both the words, but after applying the stemming process, we are not going to receive the actual root word in the output. Okay, this is an example. The next case, good after stemming, no prefix, sorry, no suffix, again this will be good. Better, again better, but what is the root word for this good and better? Good. Again good. So that is not covered under the stemming part. Okay, so this is one of the limitations that we need to cover during the execution. So before starting the practical application, I am going to discuss few of the applications where we can use this. So the common applications for the stemming, one of the application is called the search engines. Can we use this stemming facility while searching the content on the web or any search engine? I am not saying that this will solve all the problems 100%, but that will be one of the steps that will help us to track the relevant content. That is one of the application. Second is information retrieval other than search engines. If we are going to match something, just like my criteria, a job post and a user query, we can find out the relevant content related to the user query. Yes. In that case, my stemming will help us. Both the words, or we need to store only the good. Suppose if I am talking about the sentiment analysis. For that sentiment analysis, good or better? Both are positive. Good, better, or third best? There is no negative sentiment. So do we need to store, if the objective is only the sentiment analysis, so do we need to store all the three words, or we need to find out the actual root word? Only good will be appropriate to decide this thing. Like if the sentiment is good, we can classify just like a positive sentiment. So what should be done? We need to keep both or all the three, good, better, best, or we need to store only the good. We can only store good. But stemming is not going to allow this. The second technique is there, that is called lemmatization. Using lemmatization, so stemming and lemmatization, both are the techniques that we are going to use to handle this kind of issue, where we are going to find out the root word for a given word. But stemming is having their own limitation. Lemmatization is having different kind of use. So if we are working with the prefixes and suffixes, then your stemming is your solution. But if this is the scenario, then lemmatization is going to solve the problem. Okay, so now coming to the definition of this lemmatization. Again, this is a normalization technique. Okay, so both stemming and lemmatization, these comes under the category of data normalization or text normalization, which is the part of the text pre-processing. Okay, that converts the words into their base dictionary form. The word is there, base dictionary form known as a lemma. That's why the word is there, that is called a lemmatization. Okay, by considering grammar, vocabulary, and the context. And few other points are there. Considers the parts of speech. What is the meaning of parts of speech? Although we have not discussed, we will go into the next class.
Noun, pronoun, adverb.
In a sentence, noun, pronoun, adjective, adverb. What will be the application of this thing? In this topic, generative AI or any kind of text processing. Because everything, whatever content we are going to discuss related to the model development.
Sentiment analysis.
Sentiment analysis. Noun, pronoun, adverb.
For grammatical. Adverb can be used. Grammatical.
Any example?
Just better, we can classify that it's an adjective of good.
Adjective of good. Any use case?
So, for example, we are making a model for a movie sentiment analysis, and it contains adjectives like amazing, fabulous. So, it can be used to classify it.
Okay. Anyone else?
We are creating a dashboard for
ये वर्ड हटा दिया लगाया भी लगाया ना Any example? In parts of speech tagging, we are saying that we are going to identify each word present in a sentence. What is the noun? What is the verb? What is adjective? What is adverb? What is the purpose behind this process? Why we need to find out? How this may be helpful? Just tell me any application name. Behind the lemmatization was again we are going to find out the root word, but the process is different. We are going to find out the root word with respect to its dictionary meaning. So one specific rule will be applied. जैसे आप बोल रहे हैं, that is called a lemma. That's why the term there is called lemmatization. So the problem was there if we are writing good and the second person is using the word better in his statement. So good and better, the root word will be the good, or the third will be the best. The root word will be again good. Stemming is not going to provide the solution for this. How to find out the solution for this? Lemmatization is the solution, because the overall objective first, जैसे मैंने बोला कि like going. So using stemming you can delete this ing part. But went, go, went, gone. No suffix is there. In that case, stemming will not able to find out the root word. Your lemmatization will be the solution. Go, went, gone. Again, you can find the root word by applying this lemmatization. So when we talk about the application, in most of the applications, lemmatization is the preferred choice over this stemming. Because when we compare the accuracy of the responses, whatever response is generated by after applying the lemmatization, that is much better if we are using the stemming. So that's why we focus more on lemmatization, but again we can't ignore the requirement of the stemming part. Depending upon the application, we need to decide which combination will work, whether only lemmatization is sufficient or sometimes only stemming will be the right choice. So depending upon the use case that we are going to discuss. So like in this case, number of examples are there. 8, eating, eaten. The root word is again eat. If we will apply stemming, then eating will be converted into eat. 8 and eaten. Again there is a possibility eaten will be converted again into eat by replacing this en with the blank spaces or white spaces. Clear? But what about the 8? That will remain no changes. In that case, your lemmatization will help us to find out the root word. Correct? So this is the overall processing. So this worse, the root word will be bad. Best, the root word will be good. Better, the root word will be good. This is the difference between the two techniques. One is called the stemming and the second is called the lemmatization. If we want to work only with respect to the prefix and suffix, then your stemming is the good choice. But if we want to actually find out the root word from the given word, then in most of the cases your lemmatization will give you the correct output in terms of the root word. Clear? So few of the applications will be there specifically for lemmatization also. So these are the few applications where lemmatization may be helpful in comparison of this stemming. So sentiment analysis, good, better, best. The root word will be good. So we can easily continue with the sentiment analysis. There is no meaning of stemming in this case. Okay. Text summarization. Again, lemmatization will work because if we are going to generate the summary, then the main requirement will be the root word is clear so that we can find out the intention behind that word. Then summarization process will help us. This lemmatization will help us in the summarization process. Okay. Next one, chatbots and conversational AI. How this will help us? This lemmatization will help us in this application. Question answering, Q&A. How lemmatization will help us? It is the process of reducing the words to their stems only by eliminating the prefix and suffix. While in the case of the lemmatization, we are going to find out the root word. The intention is not only to eliminate the prefix and suffix, but the objective is to find out the root word in their base form as per the dictionary representation. Clear? The second point. For some words, stemming may not give the proper representation of the meaning. Okay? Stemming may not give the proper representation of the meaning. Any example? If two words are there, one is called university and second is called universal. If I will apply stemming on the first word university, TY, universal, this university. Clear? That is the case of overstemming. Second, understemming. Just connected with the underfitting.
The word is not the same.
We are trying to apply the stemming process, but my system is not going to actually perform it. Whatever expected output was required, my model is not going to generate that particular output. Like the second example is, I have taken three words: connect, connected, and connecting, and the last is connection. Okay, connect, connected. If ed will be eliminated, then I will get the root word connect. Connecting, if ing will be deleted, again connect. Connection, again if ion will be deleted as a suffix, I will get the same word, that is called connect. But understemming means what? My model knows what to do, but that is not able to accurately perform the required operation. So if the output after stemming is, my input was these four words and I am getting all these four words in the output. Actually, what should be the output? Only connect keyword should be there in the output if the stemming will be applied successfully. So under fitting, the objective was model is not ready to learn the patterns, so that output may be anything. That may be the best output, that may be the worst output. So in a similar case, if model is considering and the stemmer is considering all these four words different, then there is no meaning of applying the stemmer. That may be the wastage of resources. Okay. So this is the thing. So two terms are there. One is called overstemmer. Second is called overstemming, and the second is called understemming. In overstemming, your stemmer is going to aggressively work with the input data, and the high possibility is their output keyword may be meaningless. While in case of understemming, actually that stemming process is not applied, so we are getting the different keywords while all those input words were used for the same context. That is the second challenge that we need to handle. Okay? Any confusion till now? Stemming and lemmatization. This is the main topic that we are covering. Descriptions which are mentioned as well as the user search queries, and we are going to check how stemming and lemmatizations are going to help us to find out the related response. This is the objective. Okay? So what we have to do when we talk about stemmers, different types of stemmers are available, but two most frequently used stemmers are, one is called Porter stemmer and the second is called the snowball stemmer. Just like this, when we talk about the lemmatizer, one common lemmatizer is there, that is called word lemmatizer. So in today's exercise, we are going to work with all these three terms. One is the Porter lemmatizer, second is the snowball lemmatizer, stemmer, and the last one will be the word lematizer. These are the three terms that we are going to use. Again, we are working with NLTK. Is this visible? This code. Last row.
Yes, sir.
Okay. So first you need to import your NLTK. Then using NLTK.stem, because we are going to work with the stemming process. Okay. So NLTK.stem, from this we are going to import two stemmers. One is called porter stemmer and the second is called snowball stemmer. Snowball stemmer is much better than porter stemmer, so you can say that that is an advanced form of the porter stemmer. Okay. Then, if we are going to apply any kind of stemming or lemmatization, we can directly consider the entire data, and from where we are going to collect the strings. I have already discussed. 3 different documents, because the text data in last class I discussed. What we are going to do, either we can start with a predefined corpus, or we may start with the user defined data. If we are working with the user defined raw data values, raw data may not be available in a single file. That may be provided in terms of the different documents. So in order to apply any kind of tokenizer or any kind of mechanism, first we need to import all the data present in the different documents. So what I have done, if I am going to generate this list, then this is the string number 1 and this comma sign. It means this particular data is coming from the document number 1. Then after this we are mentioning this comma sign, then this is the second part, it means this is the data coming from the second document, again this comma sign, and this is the data coming from the third document. So each document data is going to be represented just like a single string. Each document may have number of sentences. There is no such condition that each document will have exactly one sentence. In a document, a long document may be there, but we need to represent entire content of the document just like a single string. So that's why this is the string representation. Number of sentences may be there and this separated by the comma. Just copy this statement. Be ready with the data so that we can apply the step. Now, is this visible? No? Now listen what we are going to do. First understand the process. One of the challenge was, although we are ready to apply the stemmers and the lematizer, while drafting the vocabulary from the corpus, one of the challenge was there कि if data is written in different case statements, then again for the same word you may get different words or different tokens. So during pre-processing, what should be the pipeline? What should be the basic set of steps that we need to apply while we are going to work with any application? So what is the first step? First try to understand, then start writing the code. The first step is I am going to convert the input text into its lowercase representation. What will be the benefit? Yes, strictness will be ignored. If we are having same word written in different case notation n number of times, for each word we will get a same token in the vocabulary, single token in the vocabulary. जब हम यूनिक वर्ड्स की बात करेंगे. Done. Second one. While generating this vocabulary, do we need to store any punctuation in the vocabulary? Any question mark, any exclamation sign, any full stop, any hyphen, do we need to store? That is not a valid token. But when we will apply any kind of tokenizer, that tokenizer will generate a token for each punctuation symbol also. If I am writing a don't, D-O-N'-S-N-T. Okay. Now the requirement is, if I will blindly apply a tokenizer that will give me that apostrophe S as a token. That is a part of the punctuation, which never should be stored in your vocabulary. Clear? So what we can do? Second part is we are going to work with all the punctuations, and these punctuations should not be the part of your vocabulary. Clear? So for that purpose, one single line is there. What to do? Now look at this thing. String dot punctuation. String dot punctuation covers, in general, if I am not wrong, that is covering I think 32 number of symbols. Contains 32 characters like this. ये देख सकते हैं आप. All are representing a kind of punctuations. ठीक है? So this string dot punctuation, that is going to cover all those 32 symbols that we can use just like the punctuations. So first we need to identify those punctuations. How to identify? Which one should be treated like a punctuation? So string dot punctuation is going to generate that list. What will be the list of punctuations? Okay. Then before that I am going to apply string dot make translation. Make translation is accepting three arguments. First, what to be replaced? Second argument, with which value it should be replaced. Okay. Third argument, what should be deleted. So right now, if any question mark is there, should we need to replace it with any new symbol? My objective is I am not going to cover any punctuation in my token set. So I should go for deletion, or should I go for replacement? Deletion. So मैंने बोला that is going to handle three arguments. Make translation. First is what to be replaced, with what value it should be replaced, and third is what should be removed or what should be deleted. So my objective is, before generating the vocabulary, I am going to start with all the punctuation should be deleted from my input corpus, so that while generating the tokens they should not be counted. If 20 number of sentences are there, and at the end of each sentence one full stop will be there, it means for 20 sentences I will get 20 full stops. If I will directly pass this data to a tokenizer, my tokenizer will generate 20 number of tokens for each full stop. Do we need to store this information? No, that is not a valid token. So before processing or before tokenizing the input data, we need to delete all these punctuations. So that's why this make translation, that is going to delete something if you want to delete. So whatever value you want to delete, just make it just like the third argument. First, if you want to replace this, so I am using single white space and white space. Nothing. Other than this punctuation deletion, I am not going to do any other thing. No such replacement. So in that case, I am using this blank string. Clear? Then text dot translate. After deletion, I am going to represent the data in the form of a translation table. So that is handled by this translate part. So one part we are going to represent each input value in the lowercase. Second, we are going to delete all the punctuations, and the next operation is there, tokenize. So this tokenized operation should be the first operation in this pipeline, or first we need to delete all the punctuations and converting the data into the lowercase? First we need to convert the data into the lowercase, deleting punctuations, then we can start with the tokenization. Then the token generation will be started. I think the pipeline is clear. That is the basic pre-processing. Okay. Now you can complete the code. It means whenever a content will be available, we are going to call that function for the initial pre-processing purpose. So what is the input data? In our case, what is the input data? One is job description. Second is user query. So do we need to apply this schema on both the user queries as well as the job description, or any one part? Any one? If user is writing developing software, that is the choice of the user.
Yes.
In search query, user may type anything. Means stemming or lemmatization, if we are going to apply, that will be the part that should be applied for both the user queries as well as the input text.
Yes, sir.
Yes.
Yes.
So next line is what I am going to do. I am going to call. Listen. Tokens already we have designed. In descriptions, job descriptions was there, that was a list. For each description listed in this, what we are going to do? The output is pre-process is the method that you have written, and that description will be the input. The same process we need to apply for each user query. Again, user query was written in the form of a list. So, for each user query written in the user queries, what we have to do? We need to apply the basic pre-processing, and pre-processing operations we have already declared in the form of the pre-process function. So we can call it pre-process user query and pre-process description. So on both descriptions and queries we are going to apply the basic pre-processing, and output we are going to store again in the form of the list. These two new names will be there. First complete this part, then I will show you the names of the variables. Similar output for both the estimates. In my case, what is happening? The organization is replaced by the organ. Was is replaced with WA only in case of porter. While if I am using the same input using snowball, the organ WAS, the organization was responsible. In porter, estimator was replaced by WA only. In this case, WAS, was is not replaced by WA, was is complete, and was is considered just like the input value. Okay, so I am not going to claim that this is 100% correct, but that is better in terms of the processing, so we may get more meaningful words or tokens after applying this snowball estimator in comparison with the porter estimator. That's why we prefer this. Okay. This is only the comparison side by side. So last line you can copy this. Just only print all the outputs, original job description, and the tokens which are generated in the pre-processed jobs. Then what is the output with respect to the portal customer? This is only the print statement, nothing else. So this kind of output will be there. For comparison purpose, we are going to use it, nothing else. So this is the overall working of your stemmas like porter or the snowball. Okay, so the point here is that the topic that we started is the fundamentals related to the text processing as well as the generative AI. But if we need to work with any application on related to the Gen AI or the text analysis, then first we need to understand what is the importance of the text pre-processing. For that purpose, we started with this exercise. The hands-on session was based on the text pre-processing part. Okay, so if we are going to start with any project that may handle a kind of text data, that may have the images or any type of data may be there, because generative AI is not limited to text only. If we are working with the text data only, then simple transformers we can use. If we need to work with the images and all, then different other diffusion models are there, GANs are there, we can explore those contents in order to work with those particular things. Okay. So in that
सर बस एंड करते हैं
all about from my side. If
सर फिर से
so, this is all about from my side. If you are having any query, then you may ask. All the questions are welcome. Yes. No questions. So maybe close the session. Thank you, everyone.